Start with pressure of an ideal gas. So in this case, we would be considering a cubical box of side L in this case, and we would be considering that it consists of n number of molecules. So we would be calculating pressure for n number of molecules. In it we have each molecule having mass as m. So we have made two considerations here, that is, we are taking n number of molecules that we denote it with n and mass with m. Each molecule has a mass of m in this. Now let's calculate. If we say that it has a velocity v, so we need to define velocity in each side, in each length. So it will be vxi, vyj cap, vyzk cap, as it is in all direction. They will be moving in x direction as well as in y, then in z as well. So in this case we would be calculating the molecule velocity, that is Vx. Basically we need to find the pressure, so it is dependent on velocity as well. So let's calculate it. So the first quantity is that the first molecule, denoted here by blue quantity, is in the x direction. That means it has a velocity of Vx and it is going towards the shaded region of A1 area. Here it is A1. So it will be in a positive direction, Vx will be in a positive direction, and when it rebounds with the A1 wall, it will go back in the negative x direction. So it will be towards A2 now. So one direction is of Vx, another is of minus Vx. That means if you need to find the change in momentum of this, it will be del P equal minus mvx, that is final one, then minus initial one, mvx. This is my initial velocity, this is my final velocity. So vx minus vx, so final is minus mvx, take away minus mvx, so this will be minus 2m Vx. So as you know that the momentum remains conserved in a collision, the change in momentum of the wall A1 is 2m Vx. It will be a positive quantity because as you know that the momentum remains conserved in a collision, so change in momentum of the wall A1 is 2m Vx. Now let's write the next one. So first quantity we need to define is time between two successive collisions. So it will be 2L. Now why distance traveled will be 2L? Because first it has to come here, then it will follow this path, then it will come on to the initial position. So that means 1L, coming back to the same position, again L. So that means it is 2L. Between two successive collisions, the distance traveled by a molecule between two successive collisions will be 2L. Now you know the velocity of molecule is Vx. So that means del T will be equal to 2L Vx. Now the next quantity, number of collision per second. Number of collision per second will be n equal to 1 over del T. So putting the value of del T in it, we have Vx over 2L. This is my number of collision per second. Now next thing we need to find is momentum imparted per unit time. So let's find that. it will be n number of collisions del P. So n in this case is Vx to L into del P we found is 2mvx. So momentum per unit time will be ml, because 2 and 2 gets cancelled out, ml vx square. So this is momentum imparted per unit time. Now let's move on. Next one will be force exerted on the wall A1. Let's find force exerted on the wall A1. It will be del F and it is dependent on ml vx square. It is similar to the momentum imparted per unit time. So del F is equal to ml vx square. Now we need to calculate total force on the wall A1 due to all molecules. So it will be according to all the molecules Fx, we need to take epsilon because we are talking about total value Vfx. Now if you need to find Px, pressure you know is defined as force over area. That means force value is ml epsilon Vx square and area in this case is A, and we can write AL as volume because we have area has a square unit and L has a single unit, so it will be V and epsilon Vx square. Now moving on to Py. Py will be similar, m over V epsilon Vy square. Pz will be similar again, mv epsilon Vz square. So these are three values we are given with Px, Py and Pz. We need to take the sum of pressure value. So it will be Px, Py plus Pz. So taking mv common here, epsilon Vx square, Vy square plus Vz square. So this is the value we get for pressure. Now in this case we have P equal mv over v1 square, v2 square, v3 square and so on. Why? Because we have mv epsilon v square because it is the same quantity. So we would be taking as epsilon value, we would be opening epsilon value into constituent parts. So in this case it is 3p mv. As we are calculating for n number of molecules, it will be n here, and v1 square plus v2 square plus v3 square and so on. So the sum of v1 square, v2 square plus v3 square plus v4 square and so on will be taken as VRMS. VRMS is the root mean square velocity. It is given by this quantity. Let me write the formula for it. VRMS is equal to under root of V1 square, V2 square and so on over n. Now we can replace this value here. So it will be it will be 3p equal to mn over v vrms square using mathematics. So in this case we are given with p value that is 1 by 3 mn v vrms square volume into vrms square whole square. Now let us take a look at some important points. Let me rub this all. So the final value of pressure depends on mass, number of molecules, volume, and root mean square velocity. So let's look at some important points, some expectations we have in physics. Let's see around it. First is that we have pressure equal to 1 over 3 dependent on mass, number of molecules, volume, Vrms square. Now, as you can see, that pressure is directly proportional to the mass of the gas. That means if you increase the mass, there will be increase in the pressure. So, as you can see, it is dependent on Mn. Pressure is directly proportional to Mn. That means if volume and temperature of gas are constant, then pressure is proportional to mass of gas here. Now, if mass of gas is increased, number of molecules and number of collisions per second increases. Therefore, the pressure will increase. If there is change in mass of gas, number of molecules, so number of collisions will change, and if number of collisions will change, there will be increase in pressure. Now, the second thing is that the pressure is inversely proportional to 1 by V. Now that means if volume decreases, number of collisions per second will increase. As volume decreases, number of collisions will increase. Now the next thing is that P is directly proportional to Vrms square. That means if it is proportional to Vrms square, that means it is directly proportional to the temperature of the gas. Now, if temperature increases, the mean square speed of gas molecules will automatically increase in this case. Now, let's change some of the things in the P value. So, it will be P equal 1 over 3 Mn V Vrms square. Now, in this case, we can write Mn as big M, that will be total mass of the gas. So you can write even this as mv r v Rms square. So I have changed Mn equal to total mass of the gas, that is capital M. So this could be a new formula, and you know that mv is the density. Mass over volume is known as density. So 1 over 3 density Vrms square. So this is another formula for it. Now there is another relation between pressure and kinetic energy. So as you know that the kinetic energy is half mvrms square. Kinetic energy is half mv square Rms, and we can write kinetic energy per unit volume as half mv Vrms square, or you can write it as half rho Vrms square. So the P value will be 1 by 3 of rho Vrms square, which is similar to what we get in the last equation. So this is the relation. Relation between P and E will be, how you will define this in terms of this will be P equal to 2 by 3 of energy, kinetic energy. So this is another formula. Now let's solve some of the important questions here. The first one says, root mean square speed of hydrogen molecules of an ideal hydrogen gas kept in a gas chamber at 0 degrees Celsius is 3180 meter per second. The pressure of hydrogen gas is, we need to find pressure of hydrogen gas. Let's find this out. So as I told you that the pressure is equal to 1 by 3 rho VRMS square. So in this case 1 over 3 is constant. The density is given 8.99 into 10 raised to power minus 2, and VRMS value is given as well, that is 3180. So in this question, important is to know the pressure on hydrogen gas in terms of density and VRMS value. If you don't know the formula, you won't be able to apply in this. So when you solve this, you will get your value as 3.03 into 10 raised to power 5 equal to 3.0 atmosphere. Because if you divide it with this value, 1 atmosphere, then you will get the value in atmosphere. So it will be 3.0 atmosphere. That is the D value. Let's find the second one. So in the second one, it says the temperature of gas is raised while its volume remains constant. The pressure exerted by a gas on the walls of the container increases because its molecules lose more kinetic energy to the wall, are in contact with the wall for a shorter time, strike the wall more often with higher velocities. Yeah, that's right. That they strike the wall more often with higher velocities. That's why there is increase in the pressure. Problem number 3. In this it says that a cylinder of capacity 20 liters is filled with hydrogen gas. The total average kinetic energy of translatory motion of its molecule is 1.5 into 10 raised to power 5 joule. The pressure of hydrogen in the cylinder is. Now you are given with kinetic energy. We are given with volume of the cylinder here. Now in this case you need to find the pressure. So pressure in terms of kinetic energy and volume is given by 2 by 3 EV. So you must know this formula. If you don't know the formula of 2 by 3 EV, then you won't be able to know to solve this question. So in this case, let's put all these values. Solving this, you will get your answer as 5 into 10 raised to power 6 Newton meter per square. Problem 4. So in this case, it is given that n molecules each of mass m of gas A and 2n molecules each of mass 2m of gas B are contained in a same vessel at temperature T. The mean square of the velocity of molecules of gas B is v square, and the mean square of x component of the velocity of molecules of gas is w square. The ratio w square over v square is. So we need to find the ratio in this case on the basis of mean square velocity. So mean square velocity of molecule is given by 3 kTm. This is the formula for VRMS. Now for gas A, in this case you are given that it is w square. The component velocity is w square. That means 3w square will be equal to 3 kTm. Now for gas B. For gas B, the change is that it has a mass of 2m. That means the VRMS for B will be 3 kT2m. So in this case it is given by V square. So V square is equal to 3 kT2m. So now we need to find from 1 and 2 for gas A and B. It will be 3w square, taking ratio 3w square over V square. It will be 2 over 1 by cutting down these values. So it will be 2 over 1. That means w square over v square will be 2 over 3. That means the right value is D in this case. Let's move on to question number 5. It says that a flask contains 10 raised to power minus 3 meter cube gas at a temperature. The number of molecules of oxygen are, the mass of oxygen molecule is 5.3 into 10 raised to power 26 kg, and at that temperature the RMS value is 400 meter per second. The pressure in Newton over meter square of the gas in the flask is. So we are given with volume, we are given with N value, number of molecules, mass and VRMS. So in this case we need to apply the pressure formula that depends on these quantities. It is 1 over 3 mn v VRMS square. So putting all the values in it, N in this case is 3.010 over 22 and V in this case is 10 raised to power minus 3. VRMS is 400 square. So solving these all, you will get your answer as 8.48 into 10 raised to power 4 Newton over meter square. So it is A. Let's move on to question number 6. These all questions are based on pressure. So I am just covering questions related to pressure in this video. I would be covering more in the next video. So let's do question number 6. It says a gas at a certain volume and temperature has pressure of 75 centimeter if the mass of the gas is doubled at the same volume and temperature, its new pressure is. So using this formula, 1 over 3 m v VRMS square. So in this case, as you know that pressure is directly proportional to mass. If we have VRMS, that means it is proportional to T as well. So T and V, mass, temperature and volume. So at constant volume and temperature, if the mass of the gas is double, then pressure will become twice. So that means if pressure is 75, that means the new pressure will be 150 centimeter. So the right option in this case is 150 centimeter. That's all for today's. Thank you for watching this video.